In this video, we're talking about trinomial factoring, and remember that tri means 3. So when we're talking about factoring trinomials, we're talking about factoring polynomials that have 3 terms involved. So each of these is a polynomial with 3 terms, which means they're trinomials. And there's a specific way that we factor trinomials. What we want to do is look at the first term and the third term. So at the beginning of the problem, we sort of ignore this middle term. And our factoring is always going to break down into 2 binomial terms like this. So what we're going to say is, starting with the first term, what do we have to multiply together to get x squared? Well, that's always going to be x and x. When we multiply x by x, we get x squared. Now we're going to look at the last term, 4, and we're going to figure out the factors of 4. So the factors of 4 could be 1 and 4, they could be 4 and 1, or they could be 2 and 2. Then we want to say, which of these factors can we add together to get this middle term right here? So in other words, can we add 1 and 4 together to get this value in the middle, 4? And we know that we can't. We also can't add 4 and 1 to get 4, but we can add 2 and 2 to get 4. 2 plus 2 is 4. So we're looking for a factor set of this third term, 4, that we can add together to get the middle term. So because we have 2 and 2, we're going to say plus 2 and plus 2. Keep in mind that factoring is just the opposite of our FOIL process that we do. We're multiplying out these terms. So what we can do to double check our answer is multiply these terms together to see if we get back to our original answer. So remember, when we FOIL, we multiply our first terms together and we get x times x is x squared. Then we multiply our outer terms together, x times 2, and we get 2x, so plus 2x. Then our inner terms together, 2 times x gives us 2x plus 2x. And then our last terms together, 2 times 2 gives us 4. So we say plus 4. When we add our like terms together, 2x and 2x are like terms, so we get x squared plus 4x when we add these two together, and then plus 4. And notice now that we got back to our original problem, x squared plus 4x plus 4, so we know that we did our factoring correctly here. Looking at a second example, we have x squared plus 10x plus 25, and we want to factor this trinomial. What do we have to multiply together to get x squared? Well, that's x and x. What do we have to multiply together to get 25? Well, that could be 1 and 25, it could be 25 and 1, or it could be 5 and 5. Those are the only factors of 25. Which of these can we add together to get 10? Because 10 is our term in the middle here. Well, of course, that's just 5 and 5. There's no way we can add 1 and 25 together to get 10. So what we want to say then is plus 5 and plus 5. And if we multiply that back out, we get x squared plus 5x plus 5x plus 25. And when we combine like terms, we get x squared plus 10x plus 25, which is back to our original problem. So we know that we did our factoring correctly here, and that the answer is quantity x plus 5 times quantity x plus 5. Now let's look at a couple more examples. Notice here that in the first 2 problems, everything was added together. We had x squared plus 4x plus 4, and here we had x squared plus 10x plus 25. Everything was addition, and now we're introducing some subtraction. When we're dealing with subtraction, what we want to do is use the same process that we used in the first 2 problems, but we may have to introduce some negative values to these factors that we come up with for our third term. So for here, x squared plus 6x minus 16, we have our 2 binomials here. For x squared, we get x times x. And then for our factors of 16, let's ignore the negative for a second and just think about the factors of 16. That could be 1 and 16, it could be 16 and 1, it could be 2 and 8, or 8 and 2, or 4 and 4. Now here's where it gets a little trickier. We still want to figure out how we can combine these factors to get 6, but we may have to apply a negative sign to one of them. So for 1 and 16, there's no way, even if we call this a negative 1 or a negative 16, that we can add 16 and 1, or say 16 minus 1, or 1 minus 16. There's no way with these 2 factors that we'll get to 6. Same thing here with 16 and 1. With 4 and 4, again, no matter whether we make one of the 4's negative or the other one negative, we can't say 4 plus 4 or 4 minus 4 to get to 6, so this one's out. But 2 and 8, if we had a positive 8 and a negative 2, we could get to positive 6. And that's the only way we could do it. If we said positive 2 and positive 8 and added them together, we'd get 10. If we said a positive 2 and a negative 8, we'd get a negative 6, but we want this positive 6. The only way we can get to positive 6 is with a positive 8 and a negative 2. So what we want to say is positive 8 and a negative 2. And you could have flipped the order as well. You could have done x minus 2 and x plus 8 because that would have given us the same factors just in the opposite order. So we need that positive 8 and that negative 2. And if we multiply this back out, we'll see that we get back to the original problem. One other hint you can use when you're factoring trinomials and you have some negatives involved, you can always look at the sign on this third term here. So we have a negative 16 for our third term. When the third term is negative, you know that one of your factors has to be positive and the other has to be negative. The reason is because when we multiply our last terms together here, you have a positive 8 and a negative 2. A positive times a negative is always a negative, so we end up with this negative 16 here. If we have two positive terms, we'll get a positive third term. If we have two negative terms, we'll get a positive third term. So only if the signs are different will you get this negative third term. So you know when you get to these factors here that you want to make one of the factors negative because you have a negative 16. So let's look at a similar example. This is exactly the same problem, except that our 6x in the middle is negative instead of positive. So we want to do the same kind of thing here. We have x times x because we have x squared. We already know the factors of 16, and we already know that 1 and 16, 16 and 1, and 4 and 4 can't be combined in any way to get us to negative 6. So we know we have to use 2 and 8 or 8 and 2. And in this case, the only way we can combine those to get to negative 6 is with a negative 8 and a positive 2 instead of the opposite situation where we had a positive 8 and a negative 2. So in this case, we want to say negative 8 and plus 2 because negative 8 plus 2 gives us a negative 6 in the middle. And this makes sense because the sign on our third term is negative and we have different signs, a negative and a positive, which we know multiplied together will give us a negative value for the third term. And if you want to double check yourself, multiply this back out to see if you can get back to this original problem. One last example we want to look at, we have x squared plus x plus 1. In this case, if we try to factor here, we'll get x times x. Then our factors of 1, the only factors we can multiply together to get 1 are 1 and 1. But there's no way that we can combine 1 and 1 to get to 1 in the middle. Remember, this term in the middle here is just 1x. This is x squared plus 1x plus 1. There's that implied or understood 1 as a coefficient in front of this x term. Well, if you have factors of 1 and 1, for this one here, you can't say 1 plus 1, that would be 2, we have a 1 in the middle. You can't say 1 minus 1, that would be 0, we have a 1 in the middle. And you can't make one of the factors negative and one of them positive because the sign on this last one here is positive, which means that the signs of the factors have to be the same. Since there's no way we can combine these factors to get to a positive 1 in the middle, we say that this is not factorable.